Okay, let's pause here and recap where we are in terms of the different methods that we've introduced to calculate chain length or molecular weight. And we introduced two different average quantities to do that, a number average molecular weight and a weight average molecular weight expressed by these equations. Notice that the weight average molecular weight, because it weighs the more heavier or more higher molar mass fractions of the distribution curve more heavily with this NI squared term, that this is going to give us a result that's greater than the number average molecular weight. So the weight average molecular weight is greater than the number average molecular weight for this reason. Okay, so let's try to illustrate this in terms of an example, a simple example, but at least it will give us opportunity to practice these kinds of calculations. So I'm going to propose a simple scenario where we have a distribution that's relatively simple. So say we just have two components to our distribution function. One component has a molecular weight of 500 grams per mole, so these are short fragments, and we have 8 moles of those. That's the number that we have. And then we have a second fraction that has longer fragments. These are 2,000 grams per mole in terms of their molecular weight, but I have fewer of them. I have 2 moles of these longer molecules. So let's see what we would calculate for molecular weight averages for this simple distribution. So the first one we can think about is the number average molecular weight as expressed by this equation here at the top. So what I would like to suggest is that you pause the video right here and see if you can calculate this molecular weight average and then restart it and we'll see how you did. Okay, so if we want to do this calculation, we know that we need to add up the NI, MI terms and divide by the total number. So I have 8 moles of fraction 1. That's 500 grams per mole. So N1, M1 is 8 moles times 500 grams per mole. And then in my second fraction, I have 2 moles. That's my N2. And the molecular weight of that fraction is 2,000 grams per mole. That's my M2. And then the total number in the denominator is 8 moles plus 2 moles, or 10 moles. So notice that I have a product of moles times grams per mole. So this is as units of grams in the numerator. So I have 4,000 plus 4,000. So 500 times 8 is 4,000, and 2,000 times 2 is 4,000. So in my numerator, I have 8,000 grams. And in my denominator, the total number is 8 plus 2, or 10 moles. So my total number average molecular weight for this sample is 800 grams per mole. Okay, now that we've calculated the number average molecular weight, let's try calculating the weight average molecular weight. So again, I'd suggest that you pause the video here, see if you can do this calculation, then start it up again, and I'll talk you through it. Okay, so again, we have our relationship. Let's use this one since we're given the number fraction and the molecular weight of each fraction. So here I have NI, MI squared. So I have 8 moles times 500 grams per mole squared. And for the second fraction, I have 2 moles times 2,000 grams per mole squared. And then in the denominator, I have the product of NI, MI, which is the weight. So I have 8 moles times 500 grams per mole plus 2 moles times 2,000 grams per mole. So this gives me some different quantities. So in the numerator, I have, I think, 2 million plus 8 million. And this quantity has units of grams squared per mole. Because notice I'm multiplying grams per mole squared times moles. So that gives me grams squared per mole, and then the denominator I have moles times grams per mole, so that has units of grams. And so I have 8,000 grams. So this adds up to 10 million grams squared per mole in the numerator, divided by 8,000 grams, gives me a result for the weight average molecular weight of 1,250 grams per mole. So notice that as we suggested here, the weight average molecular weight is greater than the number average molecular weight, which was 800 grams per mole. Okay, so with this framework, then we can understand how to do these calculations for molecular weight distributions of any size, it's the same procedure. You probably would just have more than two components to your distribution function.